technology. I also made a telegami, but you know, we'll look at that one Monday too. Telegami. It's the kids think it's uncool, but they're like it's very weird. But basically, you make this little person, and then you can take a picture of like a math problem, or you can find a picture and make it as a background, and then you make this little person and you record over it, and then that person's talks and moves their hand around with your voice. So it's like your own little animated person. Do that too. See the ways you can get around making a video of yourself. I realized also I could have done a Draw My Life with this board, and it would have been way more technologically advanced than my little whiteboard in my room with my red marker in poor lighting. So maybe one day I'll be super famous. Maybe. Or maybe I'll just start using the chalkboard again. So that could happen also. Find the max and min of this function. They call this the objective function. This is really useful in story problems, because you guys hate story problems. But they give you problems of like, I remember there's one in Algebra 2, in the Algebra 2 book of like, if you mow yards, you get paid this much, but if you landscape yards, you get paid this much, and you can only do this many yards, and you can only landscape this many yards, and what's the maximum amount of money you can make, how many yards should you mow, and how many should you landscape. And you have to come up with all these constraints. These are all the restrictions, and then you use the restrictions to find the maximum and the minimum. But step one, you just have to graph these. And so to graph these, you just have to put these in slope-intercept form, right? I hope that maybe we can do slope-intercept form very well. I'm going to subtract 3x over. I'm going to divide by 2. And this would be y is less than or equal to negative 3 halves x plus 8. And if I'm going to put this one in slope-intercept form, I would have negative x plus 22, and divide by 4 would become negative 1/4 x plus 22 fourths would be plus 11 halves, or that's 5 1/2. And x is greater than 0, y is greater than 0. If you ever do a story problem, they don't usually give you these constraints, but you can't mow a negative amount of yards. You can't sell a negative amount of shirts. And so those are kind of like the implied constraints when you're doing a story problem, because usually you can't have negative values. So usually you're restricted to the first quadrant, because x and y greater than or equal to 0 means you're right up here. Now, I gave you graph paper for your homework because you want to be very accurate when you're graphing, because we're trying to find the points where they intersect. If they don't intersect at a nice point, or you can't tell where they intersect, you're going to have to go back and do some algebra, like maybe do some elimination or substitution to solve these. I'm going to try to graph very nicely, but we'll see what happens here. Y-intercept of 8, and a slope of negative 3 halves. I tend to make a lot of points when I'm doing these, because I want to be as accurate as possible. So instead of just making 2 dots and winging it, I try to make a few dots and then wing it. It's still pretty terrible at times, but like that. And then let's change the left here. If I do this one at 5 1/2, I'm just going to go like right in the middle there. And then if I go down 1, I'm still going to be in the middle, and over 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Which means if you find where all these overlap, everything in the first quadrant, so that's here, and it's everything below both of these lines. So it would be this little 4-sided shape here. Are you with me on that? I don't spend a lot of time talking about these, whether they're bounded or unbounded. In Algebra 2 you did, but a lot of times you get this closed shape, which means for sure you're going to have a maximum and a minimum. But sometimes it's not closed, like one side is just open, which means you might not have a maximum or minimum. Like you might just have one, because it just keeps going forever. It's not, we call that an unbounded region, where we call this a bounded region, okay? So what we need to do is we need to find the where these cross. So I can see right away that here is a vertice, so that's going to be at 0, 0. I know this one, right, because it was a y-intercept. That was at 11 halves, so that would be 0, 11 halves, or 0, 5.5. And then I'm pretty sure this one, we can check for sure if we want to verify. But I'm pretty sure this point crossed right where that other point was, which was at, I think it was at 2, 5. And the only reason I know that is because I made a green dot there, and then I saw my red line go through it. I don't know, does yours look like that? So we could check, like if you wanted to make sure that that really worked at 2, 5, you could take the two lines, we could do elimination, or we could take these two lines, and you could plug 2 and 5 in there and make sure that it works. And it does. If I plug in 2 here, 2 plus 20 equals 22. And if I plug in the top one, 6 plus 10 is 16. So it kind of verifies that 2, 5 is where they cross. And then what about this one? 1, 2, 3, 4, 5, 6. It kind of looks like it crosses at 6, but it kind of looks like it's off a little bit. Second hour said we should just wing it and say it crosses at 6. But I said maybe we should actually say where does this line, which is this one, where does this line touch the x-axis, which means where does it equal 0? And so if you set negative 3 halves x plus 8 equal to 0, I don't think it's going to be exactly that, is it? You get negative 8, and then I could multiply by negative 2 over 3, and I would get 16 thirds. Well, that's terrible. 1, 2, 3, 4, 5, 6. 5 and 1, 5 and 2 thirds. Yes. 5 and 1 third. 5 and 1 third. Any clue what I'm saying here? I'm just gonna say 16 thirds. So, how is this different than algebra 2? Well, first of all, maybe you don't remember doing this in algebra 2, but you really did. But most of the time in algebra 2, they didn't cross at a decimal. Like, they were really easy points to cross. I remember on the test, if Mr. McClure used my test that I made for this chapter in Algebra 2, I gave a bonus question that crossed at fractions, and you had to figure out by using elimination to get the answer. But other than that, all the other ones crossed at nice points. So how do you figure out which one's the max and which one's the min? You take them and you plug them into the objective function, and whichever one gives you the smallest number is the minimum, and whichever one gives you the biggest number is the maximum. Since all these are positive, can you tell which one's going to be the minimum without actually plugging it in? 0, 0, right? If I plug in 0, 0 there, it's going to be 0, and I'll write it out in a second. Usually, it doesn't help to have a minimum of 0, because that means you're not making any money, right? Like, yes, it would cost the least amount of money to produce 0 items, but that means you're making the least amount of money too. When we did this in Algebra 2, I would always say, like, these are your points that you're checking, and then you write your equation here. And you don't have to make this table, but basically you just check all the points. If you plug 0, 0 in here, what do you get? You get z equals 0. If you plug in 0, 11 halves, you get 0 plus 5 times 11 halves, which is 55 halves, or whatever that is, a decimal. If you plug in 2, 5, you get 6 times 2, which is 12, plus 5 times 5, which is 25, which is 37. And if you plug in 16 thirds and 0, you get 6 times 16 thirds plus 0, so that's going to be 32. 55 halves, that's not 30. So what is my biggest number? I can say that my max is 37, and it occurs at 2, 5, and my minimum is 0, and it occurs at 0, 0. Looking at it from this point of view, it doesn't seem very applicable. The story problems are very long, which is why I didn't put one up here. I don't think I made you do one on your homework tonight. But there are story problems in here that you can see where you can use those. And in Algebra 2, you do the story problems. I'm just lazy and not doing them. But just know the process. Find the area where they intersect, find the points, plug them in. And there is one for sure on your homework, I know, that like it's open, so that means it doesn't have both a max and a min. You have to kind of look at it, and I'm sure we'll talk about it tomorrow. Actually, if you'll open your book to page 624 really quick, look up that 29 and 30 just so you can bounded and unbounded. And the little, where it says group activity at the top, 29 and 30, 29 is a bounded graph because it's a closed figure. 30 is an example of an unbounded graph. Do you think 30 is going to have a minimum or it's going to have a maximum? It's going to have a minimum because you can kind of see that there's a stopping point. One of those numbers is going to give you a minimum. But you see how it's just shaded on forever? Those numbers are just going to keep getting bigger and bigger in the shaded region. So 30, I could say just by looking at it, is not going to have a maximum because the maximum is just going to keep growing. So when it's unbounded, you might not have both a maximum and minimum. So you won't have both a maximum and minimum. Okay? And then 37, 38, 39, and 40, those are kind of applications of where you can look at linear programming. The harder part of those questions is the reason that the story problems are this long is because they have to give you the wording so you can write all the constraints, and that's what people hate doing. But you have to write all the constraints, and you have to write your function to maximize or minimize, and then you do that. And I tell you, there's one in Algebra 2 book about mowing yards because I remember. Oh, mowing yards and raking leaves, that's what it was. Because I remember. So, that's exciting, right? I think this is the last thing they're ever learning from me in Precalculus. Except for cool technology. Yesterday I told you to do these problems. If you did them all you have to do today is 31 and 35. Those are the linear programming. If you didn't do them all, then you need to do them all for tomorrow. I'm going to have a review assignment for you tomorrow, and we only did 2 sections. It shouldn't be that bad of a review, and then we're going to have our quiz, quest, test, whatever you want to call it. It's going in the test category, so I'm calling it a test, but it definitely won't be 100 points. But hopefully it'll be a nice, good grade to raise your grade before the end of the semester and the final. No, Courtney just finished the original test, so. But I did grade some retests yesterday, so I thought I graded them all, and then I found a bunch more in my folders from Friday, so I still have a few I'm in the middle of grading, but I did grade some of them. I haven't put them in the actual computer grade book, but I'll let you know if I have them graded. How about I let you work on this for a few minutes, and then we'll see if you have questions or get it done, and see if we want to watch my social media changing the world video that you asked to watch yesterday. No worksheet, Sam. We decided. I know you're bummed out, right? You want a worksheet? You missed this conversation yesterday that you didn't have to work.